Okay, so now here's example 2. Now, sometimes we can actually get simpler matrices or a simpler matrix when we're working on problems like this. So in this case, when we have it on, in this example, we're on R3. So we have this mapping T in this manner, right? So it's R3 to R3, right? And so the representation of T with respect to epsilon 2 and epsilon 2, so, you know, on itself, right? So the starting basis and the ending basis are the same. We could do the representation this way using the standard basis. So if we use the standard basis, we can represent it this way. Okay, and again, I'm going to let you guys work that out. Again, that would be good practice to do that. Now, if you wanted to use a different basis, for example, basis B here, so representing it with respect to this basis, we would get this matrix. Now notice this matrix here has a diagonal of zeros. I thought that was interesting. But notice here that when we represent it with respect to this basis, the representation is a diagonal matrix. Okay. Now, naturally, we prefer to, we usually prefer representations that are easier to understand rather than more complicated. Okay, now we also say, just since this came up, we also say that a map or matrix has been diagonalized when we find a basis such as this one, where the representation is a diagonal matrix with respect to the, well, in this case it'd be respect to B and B, with respect to the same starting basis as ending basis. And so what we want to find is like, hey, is there a way to find which maps and matrices are diagonalizable? And so what we're going to do is we're going to look for the rest of these. We're going to develop the easier case of finding two bases, B and D, for example, such that the representation is simple. And that's where we're going to go.